Today, everybody, we're starting operations of functions and dealing with composition of functions. So right now, we're going to be doing problem number 1 in your journal. Going to highlight f of x in blue, because that's your favorite color, right, blue?
No.
No, it's not. It's pink.
No.
No.
Green.
Okay, we're doing blue and green. Now, the very first one that I'm going to be working on is this right here, where it says f plus g of x. This is where you are adding your functions together. You're taking f of x and you're adding g of x. I'm going to highlight f of x in blue and g of x in green. And then Emily's going to tell me what f of x is equal to, because I know she's going to get it right.
X squared plus 8.
All right. And now, I'm going to ask Raymond what g of x is equal to, because I know he's going to get it right.
It's equal to 5x minus 6.
Very good. Now, my suggestion when you do these, all right, is make sure you don't have to use parentheses, okay? But I want you to understand you're taking this function and you're adding it to this function. Now, what we need to do is we need to search for like terms. I've got a 2x squared. Does anybody see any other 2x squareds around? I don't, so we're done. Now, let's, in descending order, let's look for any x's. Do you see any x's around? 5 x's, okay, I'll put 5 x's right there. That's a horrible plus sign, so just pretend like I didn't do that. Now, we have an 8 and we have a minus 6. What is 8 plus a negative 6? Or 8 minus 6? 2. Wow, brilliant. And by the way, everybody, this is your final answer when I say, what is f plus g of x? This is both of them combined. Now, before we move on to the next one, I want you to make sure that you guys have this portion right here in your journal. So when you're looking for the sum of two functions, you've got to make sure you add them together. So make sure you have that. Now, the next part I want you to do is put D for domain. And it's going to ask you, what is the domain of each new function? The domain is what x values are allowed to be plugged in. Do you see any x value that wouldn't work if you were just to plug in values for x? 0 would work. If I plug in a 0, that's 2. Now, basically the domain, everybody, is you can plug in any number going from negative infinity all the way to positive infinity. So any number can be plugged in here, and it'll still be a function. Okay? This is just a quadratic function because of the x squared. All right, so there is f plus g of x. I'm going to scroll down here. Do the next one. We're going to say f minus g of x. Write down f of x minus g of x. I'm going to highlight blue, green. I'm going to open up parentheses. Minus, open up a parentheses. Okay. And Jade, you're going to tell me what f of x is equal to.
It is equal to 2x squared.
Good. And Kaylee, you're going to tell me what g of x is equal
5x minus 6.
to. Now, this just stays the same, right? 2x, better x there, x squared plus 8. Now, this is where students, if they make a mistake, this is where they make a mistake. They usually remember to take away the 5x, but they forget to take away the negative 6. They forget a negative times a negative is a positive, and that's why they get this one wrong. So my suggestion is, when you do f of x minus g of x, make sure you put g of x in parentheses. Just a suggestion. Now, I still have what? 2x squared. But now I have a minus 5x. And now you have to take 8 and 6 and add them together to get 14. So my final answer for f minus g of x is 2x squared minus 5x plus 14. So make sure you have this pattern right here in your journal, and you have final answer. Once again, everybody, the domain that can be used is from negative infinity to positive infinity. And remember, right now, what are we writing in? We're writing in interval notation. Okay, moving down here, we're going to write f times g of x, which means you're taking f of x and you're multiplying g of x together. So whatever this function is, you are multiplying it to the other function. So we're going to take 2x squared plus 8. We are going to multiply that to 5x minus a 6. So in order to do this, we need to review the FOIL method, correct? At this point in your life, everybody should know how to do the FOIL method. But just in case you don't, do it just one more time. 2 times 5 is 10. X squared times another x gets me to x cubed. Very good. We're going to multiply all the way out here. 2x squared times a negative 6 is a negative 12x squared. Now we're going to take this 8 and multiply it to the 5x. And that's going to give us 40 x's. And then 8 times a negative 6 gives us a negative 48. Now the nice thing about this answer, do you guys see any like terms that you could be adding together? No. So guess what? That's our final answer. This one wasn't too bad. Didn't have to worry about combining like terms. This is your final answer. Now, it's a long equation right here, long function. What's your domain? Your domain is still from negative infinity to positive infinity. They're like, I don't understand. Like, what's going on right here? How do I know that portion? Let's go to grab the calculator real quick. Let's type it in. Now I'm going to change my window. I'm going to go from negative 100 to positive 100. I'm going to count by tens. Go from negative 100 positive 100, scale it by 10, go to y equals, figure out these size functions. All right, so we have 10, then it's x to the third. Then what was the next part? Minus 12 x squared. Then it was plus 40x. Minus 48. By the way, what's the y-intercept of this graph? Not even have to look at things. What's the y-intercept going to be? Negative 48. That's why I made this graph really big. Okay. It's a graph. Take a look at it. Wow. I guess I'd have to zoom out even more. All right. So we'd have to, by the way, let's check our table real quick. Wow. You can really tell that this graph is really, really, really negative and towards negative infinity. And guess what? What's the end behavior? As x is approaching positive infinity, y is approaching positive infinity. As x is approaching negative infinity, y is approaching negative infinity. So we really can't see the graph. Why not? Because, well, that right there, we have to zoom out a lot to see any changes. There's not going to be very many. So right now, that's your domain. It goes from negative infinity to positive infinity. All right, last but not least, we have f over g, or f divided by g of x, which means you're taking f of x and you're dividing it by g of x. Now, sometimes these can be a little bit tricky, okay? This one is not. This one is not tricky. I'll give you an example of a tricky one. So what is f of x again? It's 2x squared plus 8, and g of x is 5x minus 6. By the way, 5x minus 6 does not perfectly divide into 2x squared plus 8, so we have to kind of keep it this way. So this is your answer. So this right here, that's your answer. If I said, what is f divided by g of x? You would just write 2x squared plus 8 over 5x minus 6. However, the domain is a little tricky. All right? What are we never allowed to have the denominator equal? It would be bad. 0, right? So if I set 5x minus 6 equal to 0, and I added 6 to both sides, we got 5x equals 6, and then divided both sides by 5, you would get x equals 6/5. So by the way, this would be a bad number to plug in there, because if you plug that sucker in, what happens to the denominator? It equals 0. So I'm just letting you know, x cannot equal that number. All right, so then in the domain, here's how you could write the domain in set builder notation. You could say the set of all x values such that x cannot equal 6/5, and x is an element of the real number system. Now, how do we write this as interval notation? Here's how you would write it. You're basically saying this. You're going from negative infinity all the way over to 6/5. No, we don't want it to be a hard bracket. We don't want it to equal 6/5. We want it approaching 6/5. And then we're going to go from 6/5, not touching it, soft bracket, not touching it, going towards positive infinity. So this right here, this is your answer in set builder notation. And this is your answer in interval notation. And we're going to go ahead and graph this so you guys can see what the graph looks like, right? So right now what I'm going to do is I'm going to go to the graph, hit y equals. So I'm going to clear this out, hit alpha y equals. Up here, type in 2x squared plus 8. Down here, type in 5x minus 6. If I'm going too fast, you can always pause me, rewind me, and play it again. All right. Now, we're going to go to the window. We're not going to make it this big. Let's go from negative 10, positive 10. Let's make the x scale 1 instead of 10. Negative 10, positive 10. Make the y scale 1. Take a look at this graph. Nice. Okay. We got a slant asymptote and a vertical asymptote right here at almost looks like a 1.2. Well, you're not going to believe what 1.2 is equal to as a fraction. 6/5. Okay? And then we have a slant asymptote, looks like it goes right about here. Now, this video is not going to cover how to find slant asymptotes because we don't have time, but later we'll talk about how to find slant asymptotes. All right? So right now, what I'd like you guys to do is watch this. Right here, this is going towards what? That's going towards negative infinity. What is this approaching right here? This is approaching 6/5, not x. The domain is approaching 6/5. What's the domain over here? 6/5. What's the domain? Where is it going towards? Positive infinity. So there's where you guys can see this answer going down, going down, going down. Oh, right here. There's your domain. So everybody, what's your answer for this problem? This is the two functions being divided, and this right here, if you wanted to keep all of your answers in interval notation, this right here is your answer in interval notation. And this is your answer in set builder notation. Okay? Your job is to do number 2. Oh, sorry. Go back. What do you need? Right there? All right, there it is. We'll go ahead and stop the video now.